Imagine standing on the surface of Mars, red sand stretching to the horizon, a pale pink sky overhead. Now, imagine that sky turning blue, the temperature rising, and liquid water flowing freely on its surface. This isn't science fiction. It's the goal of terraforming, a process that could one day make Mars habitable for humans. In this video, we'll explore the science of terraforming, the challenges we face, and whether this ambitious dream could become reality. Terraforming is the process of transforming an alien planet's environment to make it suitable for Earth-like life. For Mars, this would mean altering its atmosphere, temperature, and surface to create conditions where humans and other life forms could survive without heavy reliance on technology. But why Mars? Mars is the most Earth-like planet in our solar system. It has a day length similar to ours, polar ice caps, and evidence that liquid water once flowed on its surface. Its proximity to Earth and its intriguing past make it a prime candidate for terraforming. Making Mars habitable is no small task. The planet presents several key challenges. Mars' atmosphere is 100 times thinner than Earth's and made mostly of carbon dioxide. It lacks enough pressure to support liquid water. Mars' average temperature is about -60 degrees Celsius. Without significant warming, water remains frozen and life is unsustainable. Mars lacks a global magnetic field to shield it from solar radiation, leaving the surface exposed to harmful particles. Mars resources, like nitrogen and liquid water, are scarce compared to Earth. The first step in terraforming Mars would be to thicken its atmosphere. A thicker atmosphere would increase surface pressure and help retain heat. Scientists have proposed several methods. Mars has large reserves of carbon dioxide trapped in its polar ice caps and soil. Using heat to release this could thicken the atmosphere and create a greenhouse effect, warming the planet. Another idea is to deliver greenhouse gases like methane from other sources such as asteroids or moons to help trap heat. Once the atmosphere is thickened, the next step is warming the planet. Methods include: scientists have suggested placing giant mirrors in orbit around Mars to reflect sunlight onto the surface, increasing temperatures. Nuclear power devices could release heat directly into the Martian surface and atmosphere. Artificially inducing volcanic eruptions could release CO2 and other gases, warming the atmosphere. With a thicker, warmer atmosphere, liquid water could potentially flow on Mars again. Melting the polar ice caps or creating artificial lakes and rivers would provide the water necessary for life. Additionally, technologies like ice drilling could access subterranean water reservoirs. Once Mars is warm and wet, the next step is introducing life. Extremophile microbes, which can survive in harsh conditions, could be introduced to help convert CO2 into oxygen and build a foundation for more complex life. Terraforming also involves enriching the Martian soil, which currently lacks the nutrients necessary to support plant life. Microbial activity and imported nutrients could help. Advanced technologies will play a crucial role in terraforming. Robots could prepare the planet by building infrastructure, seeding microbes, and monitoring progress. This could be used to create habitats and tools using Martian resources. Satellites could monitor atmospheric changes and manage processes like mirror deployment or gas dispersion. Terraforming Mars raises important questions. Some argue we should preserve Mars in its natural state, as it may hold clues about the origins of life. Others believe terraforming is necessary for humanity's survival. If microbial life exists on Mars, terraforming could destroy its ecosystem before we have a chance to study it. While terraforming remains a distant goal, progress is being made. Scientists are testing technologies like greenhouse gas production and habitat construction in simulated Martian environments. NASA, SpaceX, and other organizations are laying the groundwork for human exploration, which is a stepping stone to terraforming. Elon Musk's vision of a self-sustaining Martian colony is a step toward eventual terraforming. The science of terraforming is a mix of engineering, imagination, and perseverance. Transforming Mars into a habitable planet may take centuries, but it represents humanity's drive to explore and adapt. Whether we succeed or not, the journey to terraform Mars will teach us more about the universe and our place in it. So, what do you think? Can we make Mars habitable? Let us know in the comments below and stay curious as we continue to explore the final frontier.